And so now we want to have a look at some inequations or inequalities involving absolute values. And we can think about this in a couple of different ways. So we've already talked about the left-hand side of this expression, the modulus of x minus 3. That essentially represents the difference between x and 3. So here we want the difference between x and 3 to be less than 5. We can probably think that through and reason that through and come up with our answer fairly easily. If the expression inside that modulus sign is a little more complicated or just a bit more complex, then we might struggle with that sort of quite logical interpretation of what this inequality is saying. So the other way we could think about this is to go back to our reference point as being 0 and think about, well, the modulus of something has to be less than 5. So what we want is for that something to be within 5 units of 0. So essentially, if we think about a number line, here's 0. So something has to be within 5 units of 0. It can go as far up as 5, not including 5 in this case, because we want it to be less than 5 away from 0. And we could go as far down as negative 5, again, not including negative 5. So x minus 3 could take any of these values in here. So essentially, x minus 3 has to be less than 5 and greater than negative 5. You can deal with that as the one inequality if you want, adding 3 to both sides. So that means that negative 2 is less than x, which is less than 8. If you'd prefer to deal with that as two separate inequalities, so x has to be greater than negative 5 and x has to be less than 5, and solve them separately, that's perfectly okay as well. So our solution set, therefore, is a set of x values such that negative 2 is less than x, which is less than 8. Or we could use interval notation, so x is an element of negative 2 to 8. Again, you should be able to check that, pick any number between negative 2 and 8, and it should indeed, when you take the modulus of that value minus 3, should indeed be less than 5. Here's a second inequality. So this is a little harder to interpret because of the addition inside. We could rewrite it as a subtraction, but let's just think about it in the same way we did the previous one. Essentially, we have the modulus of something has to be bigger than or equal to 7. So what that's telling us is that that something has to be 7 or more away from 0. So thinking about our number line again, let's put 0 here in the middle. Here's 7. And here is negative 7. So if something has to be 7 or more away from 0, that means it could be 7 above 0 or anywhere further away from 0 than that, or it could be 7 below 0 and anywhere further away from it than that. So essentially that means that x plus 4 could be in this region or it could be in this region. So that means that x plus 4 be less than or equal to negative 7, or x plus 4 could be greater than or equal to positive 7. So adding 4 to both sides, x could be greater than or equal to 11, or x could be less than or equal to, my apologies, we're subtracting 4 from both sides. So subtracting 4 from both sides, x could be greater than or equal to 3, or x could be less than or equal to negative 11. Obviously, these two sets of values don't represent one continuous interval, so we can't write them as one inequality, but we can still state the solution set. It's a set of x values such that x is less than or equal to negative 11, or, so the union, x is greater than or equal to 3. Similarly, we could use interval notation, but it's still going to involve a union, and it's just going to be just as cumbersome almost. So x could be the element of negative infinity to negative 11 with a square bracket because it's included, union 3 to infinity with a round bracket. So it's not nice, but there's the set of values. Again, you should be able to pick any number within those ranges and substitute them into that inequality to find it to be true. So in general, again, if a, the value on the right-hand side is 0 or greater, if we're taking the modulus of a function and stating that it has to be less than or equal to a, then that implies that that function has to be within a of 0. So it has to be between negative a and a. Whereas if the modulus of f of x has to be greater than a, then that function has to be further than a away from 0. So the function has to be less than or equal to negative a or greater than or equal to a. So for example, if we had modulus of x squared plus 1 has to be bigger than or equal to 2, then we could say that that means that x squared plus 1 has to be greater than or equal to, so that means it has to be further away, 2 or more away from 0, so x plus 1 has to be less than or equal to negative 2, or x squared plus 1 has to be greater than or equal to positive 2. So this would be x squared plus 3 is less than or equal to 0. Now this is going to have no solutions. If you think about the graph of x squared plus 3, it's never going to be less than or equal to 0. So we have no solutions from this branch. And here we'll have x squared minus 1 has to be greater than or equal to 0. So thinking about this, the graph of x squared minus 1, it's a parabola shifted down by 1, x-intercept at 1 and negative 1. So we can see that this function is greater than or equal to 0 here, where x is equal to 1 or more, and here, where x is equal to negative 1 or less. So our solution then is the set of values of x such that x is less than or equal to negative 1, or x is greater than or equal to positive 1. So that comes back to solving quadratic inequalities, which maybe is another skill that you need to revisit. But essentially, the ideas around the modulus are the same regardless of what is inside of that function.